Okay, so welcome back from morning tea. We have Luis Eduardo from the World Bank, and he'll be presenting on ensuring reproducibility in Stata, insights from the World Bank's Reproducible Research Repository. So welcome, Luis.
Thank you. Can you hear me now? So my name is Luis Eduardo San Martin. I am a junior data scientist at the World Bank, and I work in reproducibility and especially in reproducibility in Stata. What I am going to be presenting today is our insights that the team that I am part of, because I am not the only person who works in reproducibility in the World Bank, but I am part of a team who has been doing this for a few years by now. And I am going to present what we've learned to ensure reproducibility in Stata. I've been doing this for, I think there's been like 4 years and a half by now. My initial training when I was an undergrad was in economics, but eventually I moved into data science. And I started working in reproducibility in the World Bank a few more than 4 years ago. And before I go into the meat of this session, I want to first give you an introduction, or give all of you an introduction so you all understand what I mean with reproducibility and where do those insights that I am going to talk about come from. So starting in 2023, it was in July 2023, that working paper submitted to the Policy Research Working Paper Series of the World Bank, which is a series of working papers that are presented in the World Bank, started having a strong mandate, that's a strong suggestion, to include a reproducibility package for a paper that was published. So when this started happening, my team started reviewing the reproducibility package to make sure that the exhibits of a working paper, and with exhibits, what I mean are the tables and the figures, can be recreated with code and data that runs in a different computer than the author of authors of the paper. So we have curated and reviewed more than 200. I think we exactly have 202 by as of this morning. And these are all public research and public reproducibility packages. So if you go to this first link, you will see the papers, the working papers published. And if you go to this other link, reproducibility.worldbank.org, you will see the reproducibility packages that correspond to many of these papers. And this is more or less how they look. So they link to one another. And in the first, you have the actual working paper. So that's the result of the research, the manuscript. And in the second repository, which is the Reproducible Research Repository, you have the reproducibility package, which contains, in all cases, the code, and in most cases, the data. In not all cases, it contains all the data, because sometimes data can't be redistributed or is restricted access, but in many cases, the data is there. So any user, and this is public, in the world can reproduce and recreate the figures and tables of policy research, of a paper in the Policy Research Working Paper Series of the world. I also have to give a few more clarifications. So this is mostly economics research, and especially development economics. So this is very focused on the use of microdata, data that was collected by teams. It doesn't have a lot of aggregated or macroeconomics data, for example, but there are some examples of it. So what I am going to be presenting is based on this experience of reviewing 200 of these reproducibility packages for this kind of work in the world. And if you're wondering how this might be interesting for you, I just have these 4 points. So, in social science research, especially, it is more and more common to have a mandate by journals to now include a reproducibility packages that is linked to a paper. Sometimes they do test the reproducibility package to verify that it reproduces the results of the paper. Sometimes they don't, but in many cases it has been, and it's going to continue to be the trend in social science research, at least, to include reproducibility packages. So if you wonder how you can produce a reproducibility package in Stata, this is going to be useful. Well, also in general, this is going to be useful for Stata coders who want to make code collaboration easier with colleagues or with their future selves. Or in general, if you're an advocate for transparency and openness in science and research, this is also going to be useful. Or in any case, if you've ever noticed that you run code in Stata, it shows some results, but then you run it again, or you run it in a different computer and the results are changing and you have no idea why, then this session is also going to be useful. Okay, so having made that introduction, I am going to go to explain a bit more of these reproducibility verifications, and then I'll go with the protein of the session, which is the insights that we got from doing this. So first, I want all of us to be on the same line to what I talk about, what I mean when I talk about reproducibility. So we use this definition from Bolen et al., which is from this report for the National Science Foundation of the United States. And this was an agreement that in general, reproducibility when it comes to science meant the ability to duplicate the results of a prior study using the same materials and procedures as were used by the original investigator. So when this comes to Stata work and Stata code in general, and the way that our team interprets this definition is that there is an ability to reproduce, meaning to recreate the outputs using the same code and data inputs. So for example, if I were to reproduce the results of any research that you've done or any study that you've done, you would send to me the data that you've used, the code that you've used, and I would be able to run that in my computer, and I would get exactly the same results as you're getting. So that's what we mean with reproducibility. Also, this interpretation is, it also has a specific name, which is computational reproducibility. And I also want to mention that this is in line with the interpretation and the implementation of reproducibility that is applied, but some of the leading journals in economics. So for example, the American Economic Journal, also in the reproducibility verifications of papers that they do, implement the same meaning for reproducibility and computational reproducibility. And also to give you some numbers of the reproducibility verifications that we do, 77% of the works that we review use Stata. Sometimes there are works that use more than one software or more than one programming language. Or sometimes there is a combination. So for example, there is some part of the code that is producing some results or implementing some code in Stata, and then figures are, for example, exported to Excel, and then in Excel you produce some tables, or maybe to R, and then in R you produce some tables, or to Python or some others. But in general, 77% of the works we review uses Stata, which is a lot. So Stata is clearly the majority. And this is all World Bank research. So it's, well, in many cases, there are external co-authors also to the research that we review. Yeah, but Stata is still the majority that we have in all of this. I also want to mention that only 18% of the works that we review are reproducible after the first try. And what I mean with the first try is that when we receive what we call a reproducibility package, which is like a compressed folder with the data and the code that are linked to a paper, and it produces the exhibits of the paper, or at least is supposed to produce the exhibits of a paper. Only 18% of all the submissions that we receive reproduce the exhibits exactly as in the paper after the first try. What I mean exactly, when I mention exactly, I don't mean aesthetic changes or changes or settings in the layout of a table, or maybe the order of the rows or the columns of the table. No, what I mean is the results, especially numerical results, and also results in figures. So leaving aside aesthetic changes that can happen or changes in the layouts of the exhibits, only 18% of of the works that we review are reproducible at first try, meaning that only 18% reproduce the results that you see in the paper exhibits. And if you're thinking, but aren't you guys the World Bank? Aren't you supposed to be like very talented economists and maybe coders who, do this kind of work every day? So how is it that only 18% of works reproduce when they are reviewed by someone else? The reason behind that is that this is work from economists and not for computer scientists necessarily. And a lot of the economists that we review work for, they left school or they left grad school, like it can be 15 or 20 or more years ago, right? And especially before, there wasn't a lot of emphasis in economics training for computer science and computational reproducibility. So that's why this might be overlooked when you are producing a data code or when you are working in your day-to-day economics research. By the way, this is very similar to findings from reproducibility assessments from economics and social science research. You can check these two papers that I'm linking here, and you will see that they find very similar findings, that in general, even research that is published in high impact social science journals or economics journals, they don't tend to have a lot of reproducibility or high reproducibility rates in general. They are very low. Part of our work is also trying to implement what we call the principle of computational empathy when teams are submitting their works to us. What we mean with, computational empathy is a concept that wasn't introduced by our team. It was introduced by Lars Vilhuber, who is the data editor of the American Economic Journal. But it basically means be empathetic to the anonymous user who is not familiar with your paper, is not familiar with your data, and is not familiar with your code, but has to run your code with your data to reproduce the results of your paper. So be empathetic to them and make the work of reproducing your results as easy as possible. So do not require them to do tedious things, like, for example, do not require them to copy paste. So if you have to paste, I don't know, a column with results in an Excel tab or an Excel file, don't do that. That's not being computationally empathetic. And also that means things like make code run as easy as possible. If a one button run can be implemented, that is ideal. I am going to go back to this principle of computational empathy and how it's implemented later in this presentation. And lastly, in the final stage of what we do is, if there are parts of the work that are not reproducible, which happens a lot of time, we review the code and we collaborate with the authors to identify their reproducibility issues. So for example, we review the code and we tell them, I think that in this do file, possibly in this line, is where your reproducibility issue is starting. So you need to correct that part. We suggest correcting that with this other code that is likely not going to change your central results of your research, but it will solve the reproducibility issue. So this is all as a preamble of how is it that we know what I am going to present in the rest of this presentation. So yeah, now I am coming to the central part of this presentation, which is how you achieve reproducibility in data, which is what we've learned after a few years and after a few hundreds of reproducibility packages and words that we've reviewed. So basically, if you want to get reproducibility in data, sometimes exceptions can happen, but as long as you are complying with these 4 rules, in our experience, this will work for 99% of cases, meaning that if you meet all of these 4, it's very likely that your work will be reproducible in another computer. And these 4 are: use the same version of dependencies. With dependencies, what I mean is user-contributed commands or user-written commands that we install. For example, if you install something from GitHub, or if you install something from for the repository Statistical Software Components, the SSC repository, which is used a lot in data work, that's what I mean with dependencies. So if you use the same version of dependencies, then that's one of the conditions that usually are necessary for reproducibility. Also, use a seed number. They are going to be used for using and generating random numbers. If you're using them, that's also a condition. set the Stata version and make sure you are running in the same, using the same Stata version for your run. You know, you can set the Stata version. It doesn't mean that you have to use exactly the same installation of the version necessarily, but it means that you should use the command version. That means that after you implement it, all of the code that you're going to run is going to be interpreted as for the version you're setting. I am going to mention this later. And lastly, if you are using a unique sorting, then that's the fourth rule for reproducibility that you will have, that you will need to follow. So if you're following these four in general, then reproducibility in 99% of the cases is going to. And I want to emphasize that 99% mention because exceptions can still happen. I personally haven't seen a lot of exceptions in the works that our team has reviewed, but they can still happen. I remember when I did this presentation in the Stata conference last year, there was a mention by one of the senior programmers of Stata Corp who explained that, for example, one of the exceptions can be that if you are using a large number of decimals in a variable, or if you're using a number with a lot of characters, a lot of digits, basically, then the results can be different if you are using that for a linear regression or a regression in general, if you're running the code in a Mac computer versus a Windows computer. So in those cases, those are the exceptions, the corner cases that can still happen. But that's what I'm saying. For 99% of cases, these four will work. And I want to emphasize why these four will work. So the first thing I want to emphasize is using the same dependencies. So the reason why you need dependencies is, in the first place, because if you don't have a dependency that your code is using, this will stop code execution, right? And if code doesn't run, then of course you can't reproduce any result of anyone. You can see this example of this screenshot. So here I have a screenshot of code that is using the user contributed command rechdfe. And if this is running in a computer that doesn't have the command installed, then Stata is going to show you an error saying that the command is unrecognized, okay? There is a simple solution to it, which is to install the command. But that is, for reproducibility, only a partial solution, and I will explain why. So if you're not using the same versions of dependencies, the commands can produce different results, or they can work in ways with, so for example, they can allow options for one version of the command, but not for other versions of the same command. This is an example that our team has detected because this is a command, PDS lasso is a command that is externally contributed, is not part of base Stata, but a lot of Stata programmers and economists, at least in the World Bank, use it. So in July 2024, it was possible to install this command from SSC, but it was also possible to install it from GitHub. It was available in both platforms. And it was the case that the version of SSC was version, as you can see here, 1.1, but the version on GitHub was more updated because that's the one that the developers of the command used to continue publishing the releases, and especially the most updated releases of it. And it was version 1.3. And the problem with this was the version 1.1, the one available in SSC, didn't allow this option kernel, for example. So if you were using code that used this option, this is not going to run unless you have the version from GitHub. By the way, for this new presentation that I'm doing right now, I checked if this was still an issue, and I can, at least until yesterday, it wasn't an issue anymore. So it seems that the version on SSC is now in line with the version of GitHub. They are the same. So this issue for this option and this command is not there anymore, but it's an example of what can happen. And if you have time, I recommend looking at this reading. This is from a blog post in one of the World Bank public blogs. And you can see, and here is a more detailed explanation of why this is a problem and what you can do to solve it. And well, so luckily there are ways to solve this. So one of the ways is, and this is what we do in our team, is to use an ADU folder for each paper or each project. So if you know what if you don't know what an ADU folder is, an ADU folder is a folder that stores all the dependency files for the dependencies that you install for Stata in your computer. So every time you install something from GitHub or from SSC install command name, that is going to go to your ADU folder, which is by default a location in your computer. It is possible to change that location. So ideally, if you can change it for a different project or for a different paper, and then you can share that location with your co-authors or your colleagues so that all of you can make sure that you're using the same ADU folder, that's what works best that's what works best for reproducibility, right? And then when you are publishing a reproducibility package, the way to make sure this is reproducible is include your ADU folder, because that way you are like locking the versions of dependencies that you used in your reproducibility package. If you are not sure how to do this, in general, it's very simple. It's usually one line of code, the line that you use. So, sorry, it's only one line of code, what you use to tell Stata what is the ADU folder that you're gonna use. And the ADU folder is, every time you close Stata and you open it again, going to be reset to the default location. So you don't have to worry if you are changing it and then you forget to change it later, because it will go back to the same default location. By the way, my team has also prepared a Stata command actually that also solves this issue. That the name of that command is repadoo, and it's available in the package repkit, which my team has published. I just wanted to make a disclaimer that I am also promoting some of the work these are public goods that my team develops, because part of our work is not only maintaining the Reproducible Research Repository of the World Bank, but also making public any internal tool that we use for this. So this is one of the internal tools that we developed for this that is also public. And if you type SSC install repkit, you will be able to use repadoo, which is one of the packages that we've developed as solutions for reproducibility in general in Stata. And you can see after that the help file of repadoo to check how it solves this. So that's the problem with dependencies. Then I also mentioned two other conditions for reproducibility in Stata, which were the seed number and the versioning of Stata. Okay. And in many cases, and at least in my experience in reviewing reproducibility packages in the World Bank, what I've seen is that users and Stata coders and Stata programmers and economists are more likely to be aware of the seed number, but not necessarily of the versioning as a condition for reproducibility. Check this screenshot that I have here and check the first two columns. So here I am using the same seed number. So using a seed number, what it's gonna do is that when you generate random numbers, this is like telling Stata where in the pool of random numbers that it has pre-programmed to draw the random numbers from, right? So if you use the same seed number, Stata is gonna know, okay, so I need to start here, and I am drawing these random numbers, and they are going to be the same, or they are supposed to go to be the same, right? You can see here that the first piece of code in the first column, this is setting the version to Stata 12. This is the command version. And the set of 10 random numbers which is being drawn is the same of the ones that are set if I set the version to version 13. Okay, these two are the same. But on version 14, even though I am using the same seed number, the pool of random numbers changed between versions. And this was the last time until now that the pool of random numbers changed. You can see that the seed number is the same, but this is a different set of random numbers than the first two. After version 14 until now, the pool of random numbers that come preloaded in Stata are the same, but we don't know if in the future they are going to change again, right? It's possible. You know, there are releases of Stata. I think they come in general once every 2 years or 3 years. I remember, well, Stata 14 came, I think, in 2014 or 15 or less, and now we are with version 18. So The bottom line of this is, if you want to ensure that your code remains reproducible for as long as possible, you need to set not only the seed number, which is something that many users know, but also the version, okay? Even though if your code is supposed to run on your current version of the state that you have installed, and you might think, well, but this is redundant. I have a state 18 and I want it to run in state 18. Why should I set the version to 18 if it's going to run in 18 by default? The reason is because if you want your code to continue being reproducible, you should be explicit about it, okay? Because we don't know when in the future the pool of random numbers is going to change, okay? As it did from version 13 to. So these are the second and third condition for reproducibility, and I am going to talk about the fourth, which is, in my experience, a little trickier to understand and to have in mind, because this is not as, it's less obvious than the others. So the third is the problem with non-unique sortings in Stata. Not all users in Stata are aware that by default, Stata handles ties in sorts randomly. So ties in sorts, with ties in sorts, what I mean is, if you are sorting by a variable that is not unique, you are going to have observations that have the same value of that variable, right? And then if you sort by that variable, sometimes for the same, within the same value of the observations, sometimes within the same value, an observation is going to come first in the sorting, but then if you run that piece of code again and sort again, then another observation is going to come in a different order within the cases where you have ties in observations. I think I'm not explaining this clearly, but in general, what I mean is, wherever there are ties in the sorting of observations, Stata handles, it solves the ties random. That's the key point. So if you don't handle this correctly, this can also be a problem for reproducibility. And this is, in my experience, one of the more common reasons why when you run the code once, it produces results. But if you run it again, it can produce different results. So the results of your code are unstable. You can see check the first block that I have in this slide. So this is an example of a non-unique sort. So here I am setting the version, I am setting the random seed, and I am sorting by the variable HHID, which is short for household ID. And I am generating random numbers after that. So you can see that the random numbers in the first and second round, they are the same, okay? But you can see that they are being assigned to different person IDs. This data set is supposed to recreate microdata of household individuals, for example. So you will have that within a household, there are different people that live in that household, and you're generating one random number for each of them. That's the case that is supposed to be recreating, which if you work with microdata is more or less common. This can happen. And you can see here that, for example, in the first round for person ID 1, the random number 0.94 is being assigned, but then in the second run, this random number is assigned to person ID 2. So this is not going to be reproducible. And if you run a code like this on this data again and again and again, this is going to give you different results. So the random numbers generated, they are going to be the same, but they are going to be assigned to different observations. And that's where the problem with reproducibility comes. A way to solve this is, instead of sorting by a variable that has ties in the sorting, make sure to sort by a unique variable. I said before that this data is supposed to represent microdata about individuals who live in households. So instead of sorting only by household, sort by household and individual, right? Each individual is unique, so that way you'll have a unique sorting, and then you can make sure that the random numbers you're generated are assigned always to the same observation, and that will be reproduced. I'm going to make a pause to drink water for it. Okay. So this is one of the ways in which you handle non-unique sorts in Stata. And I have to say one of the ways because there are other ways that you need to know and be aware of to handle this properly in your code. So I already mentioned the first, which is use unique sortings basically. And one of the most like the more convenient commands to do this is instead of using sort, use the command isId. So the command isId, what it does is checking if one variable or set of variables uniquely identify, meaning that they have unique values for your observations. And if you use the option sort when implementing the command, then you are not only going to be sure that they are unique, but that also they will be sorted. So this solves your problem. However, you can still have another problem. And for that, you need to be aware of implicit sorts that the Stata applies when using other commands. With implicit sorts, what I mean is that sometimes when you apply other commands, for example, this happens with merge, which is very common to use. Stata doesn't tell you that the sorting of your, I mean, it doesn't give you a warning. It usually doesn't show you like any, printed message saying the sorting has changed or the sorting is now this, right? So you need to be aware when this is happening because some of those sortings, when they are changing by the use of other commands in Stata, they can be non-unique sometimes and they will mess with reproducibility. These are some of the cases that we in our team have identified by working with these 200 plus reproducibility packages that we've reviewed. So for example, when you do a merge from one to many, there is an issue, which is that Stata will sort observations by the key variable, but randomly within the key variable. A solution to this is to add a unique sorting after the merge. This doesn't mean that if you don't add a unique sorting after a merge and you're merging from one to many, you will necessarily have a problem with reproducibility. But it can be the case that you have a problem with reproducibility and you're introducing a problem with reproducibility and you're not aware of it. That's what it means. Another problem which can happen with implicit sorts is when you use by sort. Well, by sort is actually sorting, right? But if the variables by which you are sorting don't produce a unique sorting, then whatever creation or generation of a variable that you're applying might introduce problems with reproducibility because the sorting might not be unique, right? A solution to this is instead of using by sort uniquely first and then use by separately. And that will solve the implicit sort of using by sort. Another problem that can happen is in the forced dropping of duplicates, which is done with this command, duplicates drops variables, comma force. The problem with this is that Stata will randomly select which observations is going to drop after sorting, if the sorting is not unique. And the solution to this is a bit more complex. What you should do, instead of forcing a duplicate drop, think of why you have duplicates in your variable first. And based on that, choose a criteria based on your assessment. So for example, maybe you can only keep the observation that was collected first, or only keep the observation that has less missing values across all the variables. Those are examples of criteria that you can apply. But in general, forcing the dropping of duplicates using this command, this is going to mess with reproducibility of your results very probably. I also want to, I still have time. Yeah, I want to make an important comment of avoiding using set sort seed. So this is a command that is especially experienced Stata programmers know of. And basically what set sort seed does is it allows you to use a seed. It's a seed number. So it's similar to set seed. But instead of being for the generation of random numbers, it's for implementing the same random state in the random. Sorry, I'm going to say it again. So It's for setting the random state in the case when Stata has to deal with ties in the sort. Okay, so if you use set sort seed 1000, for example, and you run that code, and then you run it again, the order within the ties in the sorting is going to be the same for your computer. So this is a partial solution. And the reason why I say this is a partial solution, and you in general should never use it if you want your code to be fully reproducible, is because set sort seed only gives reproducible results within the same Stata edition. Okay, so it works. I mean, if you run it in your computer with the same Stata installation, it's going to work. But then, if you run it in Stata standard edition, but then you have a colleague who has a Stata multiprocessor and they are running it in their computer, the sorting, even when using the same sort seed number, is going to be different. There was an important, a very interesting comment from Hoa Peng, who is one of the senior programmers in Stata Corp, where he was clarifying this in this post, in this discussion in the Stata forum. I am going to read the part that is highlighted here. Stata SE and Stata MP use the jumbler differently and so produce different orders of ties, even when starting from the same seed. So any reproducibility produced by set sort RNG state is the same as set sort seed. It's specific to the edition of Stata that you are running. Okay, so this is not sufficient for reproducibility, and you should avoid it. There is also a document in Stata's longer documentation for sort that has a mention for sorting with ties. You can also check it, and it basically warns you against using sort seed. Instead, what it recommends is to think about your problem when you have ties in your sorting and you need to sort by a variable that has ties in the sorting, and create, and after thinking and after considering why you have ties in the first place and how you can get from that to a unique sorting, after thinking and considering all of that, Stata recommends that you create a unique ordering based on that and based on what you need. So yeah, so the bottom line of this is avoid using set sort seed. It's only a partial solution for reproducibility. It's not a total solution. Okay. Lastly, I want to mention also other things. These are not related specifically to reproducibility or computational reproducibility, but to transparency in general. If any of you are looking to make your code easier to be understood or more transparent, or to publish it. And so this goes beyond code execution. So I said before that I would explain a little bit more about computational empathy. This is the part where I'm going to do that. So the implementation of computational empathy basically means that you're going to have a self-contained reproducibility package. You're going to have a main do file with all the settings that are needed to run your code, like, for example, the versioning, pointing to the internal ADU file if you're doing that, or if you're using any special format for the figures or any special format for the tables, all of that should be set in a main do file. Ideally, this main do file should also run any sub-do file that you're doing, that you're using. So for example, if you have one do file for data cleaning and another for data construction and another to generate figures 1 to 4 in your paper, and then another for figures 5 to 10 in your paper, all of these sub-do files should be run by the main do file so that they allow a one-button reproducibility. And then, of course, clear code and clear documentation of your reproducibility package. I want to explain a little bit more of what I mean with self-contained reproducibility package. You can see the screenshot here. So this screenshot, what is showing is a suggested folder organization and file organization in general that is going to be very clear for someone who is unfamiliar with your paper and unfamiliar with your code and data to understand where things are. Okay, so if I am a reviewer of this reproducibility package and I see this organization, I can have an idea, okay, the do files that I need to run are probably in this folder 2-code, right? And the data is probably in 1-data. And the outputs are exported to 3-outputs. So that's a good self-contained and organized reproducibility. Then about the main do file that sets all the settings and allows one button reproducibility, this is an example of only the first part of do file that does this. You can see that this is divided in parts, and this is using the sections that you can, the sections that you can use to organize do files that come in the Stata do file editor to differentiate each part. So there is a part one that is doing the setup. There is a part two that is preparing folder paths and defining programs, and then is a part three that is running the sections. And you can see that in part two, in line 26, there is a global that is being generated that is called project folder. And this is good for file organization and also for one button reproducibility, because after this global is set, all of the other folder locations are set relative to that first global, right? So if I am going to run this in my computer, I just have to modify line 26 to my own folder path. And if any of you want to run this, you just have to modify line 26 to your own folder paths. And then everything else is already set relative to that location so that it will run. Then on the other 2 points, code readability and documentation, I think that this, especially for code readability, this quote, which was done in 1985, so this is a lot of time ago, right? But it still applies. I think this summarizes very well something that, at least in my experience working with economists, people don't tend to have in mind all the time, which is that programs must be written for people to read and only incidentally for machines to execute, right? So think that the code that you're going to produce, and this, this applies not only to Stata code, but to programming and coding in general. If you're doing code for research, of course, your code needs to work, needs to run without errors and produce the results that you're showing in a paper. Of course, that's necessary. But the fact that you need the code for that is only incidentally. You're going to produce your results only once, right? And if you're looking your code to become a public good, to be published, to be referenced, to be useful for other people so that they can build on it, they can review it, they can modify it, they can understand, they can learn from reviewing the code, then it's actually not only important that your code works, but that your code is, as neat as possible, as understandable for humans as possible. A machine is not going to care if your code if it looks pretty or not, or if it's understandable or not. It's just going to execute it. But for a human reviewer, especially if you're going to publish your code, it will make a big difference. So I think this quote here summarizes that beautifully. This also means that, of course, if your code is linked to a paper, this code should allow readers to understand the paper's logic, the assumptions, and check its correctness. There is a lot you can improve and you can achieve for this with simple measures. Things like, for example, horizontal and vertical spaces, code comments, and section headers. Check these 2 screenshots that I have here. So this is the same code, exactly the same code. But you can see that the second is much, much easier to be understood for anyone, even by advanced Stata users, only because they are using horizontal or vertical spaces and section headers. And only with that, you can achieve a lot to make your code simpler to be understood. I also need to say there is another tool that our team has produced, which is the Stata linter. A linter is, if you're not familiar with them, a linter is it's like a tool for reviewing code and telling you, the programmer, where you can improve it. So this is a public tool that you can install and use it for your code. And lastly, this is my last slide. Include documentation not only for your code but also in general for your reproducibility package for your total reproducibility package. This includes data provenance information for the data that you're using. If it's difficult for a user to understand which of the code outputs relate to the exhibits of your paper. Also include a table linking that, and include system information for the generation of exhibits in the paper. The OS in which you produce your results, your processor, the RAM of your computer, the data version and edition. Yeah, and I think I went over time a little bit. I'm really sorry for that. But that's all. Yeah, if you want to send me an email, of course you can send me an email. The first letter is an L, it's not an I. So this is my email. And I will share the presentation.
Thanks, Louis. That was very informative. I have to say I run into many of the problems you described, and I think you've come up with a new concept, reproducibility, empathy. I think that'll be a buzzword in years to come. We normally would have 5 minutes for questions, but we've gone well over time. So sorry, Louis, we're going to have to move forward and move on to the next presentation.